In the previous video, we learned how to solve a nonlinear equation by factoring, right? So we basically went through these steps. For factoring in the quadratic formula, which we haven't covered yet, you want to set the equation equal to 0, as opposed to the linear equations, which were the previous videos to that, where you want your variables on one side and your numbers on the other, right? So we're doing nonlinear, right? And we wanted it equal to 0, and we went through the factoring methods, right? And there will be links to the individual factoring methods inside that video so that you can see the individual methods, right? Now, what we're going to do is one that's not on here. We're going to cover what's called the square root principle, and we're going to kind of talk about the steps, and then I'll add to this list for the next video after this one. So the idea about the square root principle is if you have something like x squared is equal to k, then x is equal to the square root of k, or x doesn't even look like an x. X is equal to the negative square root of k. Now, what does that mean? All right. So it works something like this. Before, we had x squared minus 4 is equal to 0, right? That's what we had in the last video. And we said that's a difference of two squares, and it factors to x plus 2. X minus 2 is 0. So either x plus 2 is 0 or x minus 2 is 0. So x is minus 2 or x is 2. And the nice thing about all these methods is, you get to pick them. Now, sometimes the computer or the teacher that's assigned these problems wants a specific method done. But if they don't, you have all of these different tools to pick from. So we know that the answers were plus and minus 2 from before. But if we have this and we set it up like this instead of equal to 0, so if we have something squared equal to some number, okay, then what we can do is we can come in here and square root both sides, because remember, you can do pretty much what you want to one side as long as you do it to the other side. Now, you can't divide by 0 or anything like that. But if you apply a process, you just have to be sure to do it to the other side as well. So what happens is this square root right here is actually going to undo this square. It's going to reverse the square. So what you would have is x, because the square root of x squared is x. But remember, this wanted two answers. The degree was 2. And when you square root 4, what could have you squared to get 4? Well, if you square a plus 2, you'll get 4. And if you square a negative 2, you'll get 4. So there were two possibilities. And it may have occurred to you at some point where you're going, well, I don't think we ever answered questions like that. All right, so when somebody would say, hey, what's the square root of 16? And that was the question that was assigned to you, either in the book or on a test or something like that, it's understood, and I don't know where you were supposed to have been told that this is an understanding, but it's understood that it's asking you for the principal or the primary square root, which translates to, I want the positive one. So when they just say, hey, what's the square root of 16? You go, oh, 4. Okay, that's the principal one, the major one, the primary or positive one. But when you put the square root on both sides, you don't have the ability to say, I want the principal square root one only. You have to come up with both, okay? So when you put the square root on both sides, you are the only one who's going to remind yourself to put the plus or minus to get those two answers. All right, let's try another one. So what if we have something like x minus 3 squared equals to 5? So does it have to be equal to a square? No. So what I have is something squared equal to a number. So I can square root both sides. All right. And for the left side, the square root of x minus 3 squared. These cancel each other out, and you have x minus 3 equals. And what did you square to get 5? The square root of 5. So this is plus or minus the square root of 5. So even if you cannot simplify it, now this is really important. Even if you cannot simplify what is over there on the right-hand side, you still have to remember the plus or minus. All right? Then you would add 3 to both sides. And x is 3 plus or minus the square root of 5. So you actually have 3 plus the square root of 5 and 3 minus the square root of 5. Those are your two answers. Now I'm not going to check them both, but just to show you, right? Remember what we had was x minus 3 squared equals to 5. So let's check x is equal to 3 plus the square root of 5. So we would go 3 plus the square root of 5 minus 3 squared. Is that equal to 5? That's my question. Well, this 3 minus 3 goes away. So is the square root of 5 squared equal to 5? Yeah, it is. So you see how they check. All right. So I like this concept up here, the way books often state it, where it goes, if x squared is equal to k, then x is equal to plus or minus k. But it's not always just an x. So I have a tendency to go, if you have something squared equal to some number, okay? And that one doesn't have to be a square, all right? If you have something squared equal to a number, you square root both sides, all right? So if you look here at our list, right? If you have for something squared equals some number, okay? Then what you're going to do is square root both sides. And like I said, you don't have to make it complete sentences or a paragraph. You're certainly welcome to do it. Square root both squares. Square root both sides. Talking and writing. Okay. Don't forget the plus or minus. Every time you leave this plus or minus off, you need to come back here and put stars next to it. Maybe change the color, whatever. And then you're going to simplify, if you can, and solve. Okay, let's see if that's working out. Let's try another one. So let's try, what if you have 2x squared minus 32 equals 0? You go, well, it's kind of, sort of, almost a square. It kind of looks like it might be the difference of two squares. Let's see what we can do, all right? So let's try for that square root method. So I'd move the 32 to the other side, right? 2 is not a square, so I don't have something squared equals, I have an extra outlier 2, so I'm going to divide both sides by 2. So now I have x squared equals to 16. So now I have something squared, right? This is the only thing over here squared, equals a number, which doesn't have to be a square. So we're going to square root both sides. Square root of x squared is x. Don't forget the plus or minus, and simplify where you can. The 16, square root of 16 is 4, and those are your two answers. All right, let's try 9x squared minus 27. Well, let's get the constant to the other side. This is not looking like a square. It kind of does. 9's a square, and x is a square. But what we want to do is to see a square. We want to see something, not something times something squared. Okay, so we would have, this is 3x equals 27. So you see how this 3x squared is 9x squared. And now I just have one thing, one something squared. So we're going to square root both sides. So the square root cancels the square, and you have 3x equals, don't forget the plus or minus, and we're going to deal with the square root of 27. So we have 3x equals plus or minus. And is there a square in the 27 that's a factor? Yes, 9's in there. So we'd have 3x equals plus or minus. What's the square root of 9? 3. What's the square root of 3? 3 inside here is prime, right? Doesn't reduce anymore. But I do want to see what is going on with just x, not 3x. So I'm going to divide both sides by 3. And x is plus or minus the square root of 3. Now, this 3 cancels into this 3. It does not cancel into the square root of 3. All right? Because this is locked into a square root. All right. So x is plus or minus the square root of 3. Because remember I talked about the degree tells you how many answers you should be expecting. All right? Now, here we go. From before, the factoring reviews, you know that the sum of two squares does not factor, but you can solve it, just not by factoring. So if you move the 9 over to the other side, now you have something squared equal to some number. Square root of x squared is x. Don't forget the plus or minus. Okay, what did you square to get 9? 3. And the square root of a negative is actually considered to be the square root of 9 times a negative 1. So the square root of 9 is 3, and the square root of a negative 1 is defined to be I. Remember your i's from before? If not, I'll put a video in here to remind you, a support video. So these are the two answers. Now, look at this one. This is going to be important in future video and future techniques. This x squared minus 8x plus 16 is actually one that's a binomial square technique. So this would be x minus 4 squared. Because let's take this x squared minus 8x plus 16. And you would say, well, if it factors, they both have an x. What multiplies to 16 and adds to negative 8? Negative 4 and negative 4. Or you can just, you can factor it and then go, oh, I could write this as x minus 4 squared. Or you can use the binomial squares, which is a variation of that, which is in the description of the previous video when we go through all the factoring, right? The factoring is actually considered like a prerequisite to college algebra, but if this is, if you're following along with this course because you're in algebra in high school, they may be including it right now. All right, so regardless, go back to the other video if you're trying to find it. All right, so the square root of x minus 4 squared is x minus 4 equals, don't forget the plus or minus, and we have the square root of 20. Now, I'm going to go ahead and move the 4 over. Now, 20 is not a square, but is there a square hidden in it as a factor? Yes, 4 is in there. So you have x is 4 plus or minus. The square root of 4 is 2. The square root of 5 is 5. You cannot add this 2 and the 6 together because 4 is 4 ones or 4 popsicle sticks if you're counting popsicle sticks. And you have 2 square roots of 5. So this is the answer. All right? Now, this process of sitting here and saying, taking this right here and changing it into a binomial square, we're going to use that technique when we talk about completing the square in order to solve quadratics. So I just want to point that out so you can look at it for just a second, kind of just let it sit there and be absorbed, and then we're going to move on. Now don't forget there's some practice problems in the description, all right? And we're going to move on to completing the square in the next video.